Todas, are you there?
Sir, yes, sir, I'm there, sir.
I think we can start the session, right? So I hope everything is okay.
Okay, sir. Can I start the session, sir?
So participants, we are streaming in two different ways. You can either join by using this Google Meet or else you can also watch this with the help of YouTube live streaming. So please keep that in mind and do accordingly. So Tojas, I think you can start the session with the welcome address.
Okay, sir. Thank you, sir. So, good evening, one and all present here. We are so glad to have you all here today. We appreciate your valuable presence amidst this difficult time. Dear all, on behalf of Ramco Institute of Technology, we welcome you all for this workshop titled Introduction to Operation Research in Engineering for student and faculty members to bring you all much closer to spend this day with a thought-provoking knowledge. To begin with, I would like to welcome our dear principal, Dr. L. Ganesan, and our dear vice principal, Dr. S. Raja Karnakaran, who are a great backbone in organizing such wonderful and unique event. Welcome, sirs. Next, we would like to extend a special welcome to our chief guest, Dr. Thothathri Venugopal, Professor, Department of Mathematics and Computer Science, Sri Sathya University for Human Excellence, Kalaburagi. We are happy to have you here and thank you, sir, for joining us. I would also like to welcome our dear faculty members who are our second parents who guide us and stand by us. This event would not have been possible without the hard work and the dedication of our IE faculty coordinator, Mr. J. Jebin, and all our student coordinators. Last but not least, I extend my heartfelt thanks to all the participants for showing your great interest for today's event. Once again, I welcome all the participants for today's workshop. Thank you.
Thank you, Tojas, for your welcome address. So now I would like to give a few words about our expert speaker of today. So Dr. T. Venugopal sir is a professor of Department of Mathematics, Computer Science, Sri Sathya University of Human Excellence, Kalaburagi. Formerly, he held various positions like Controller of Examination, Director, Dean at Sri Sathya Saraswati Vishwa Mahavidyalaya. And regarding his academic excellence, he has graded 21 MPhil scholars and 10 PhD scholars. He has also graded and teach in the UG and PG degrees for about 22 years at his university level. He has published 52 research papers and 6 books. And regarding his outreach, he was also a member of Board of Studies in colleges and universities and has also given more than 30 talks on various aspects of mathematics. So with this small introduction, now I would like to hand over the session to our expert speaker of today, Dr. T. Venugopal sir. So, sir, Venugopal sir, now session, sir.
Thank you. I will take over now. Let me start. Please stop your presentation so that I can present.
Yes, sir.
Yes.
Sir, you can share on your own, sir.
Sir, your presentation is on. Okay. I think only one person can present.
Yes. Okay.
Yes, I will start my presentation. So yes, I think my presentation is visible. Yes?
Yes, sir.
Am I audible?
Yes, sir.
Yeah. Thank you. Thank you. I will start now. This is Professor Venugopal, Professor of Mathematics in the Department of Mathematics and Computer Science of Sathya University for Human Excellence, Gulbarga. So I thank my organization for having permitted me to go ahead with this webinar. And this is how you reach me. Those who wish to contact me after this can kindly take note of this. My WhatsApp number 6380551135 and the email ID is venugopal.t@sslsg.org, or you can reach me on my YouTube channel also. Yeah. So this is the welcome to the online workshop on Introduction to Operational Research in Engineering. I thank the authorities of Ramco Institute of Technology, Rajapalayam, for having invited me to talk in this webinar on 22nd November 2020. I first have a disclaimer. This concept of operation research modeling, I will do this operation research. I will show about the modeling and solving operation research problems through spreadsheets. I like spreadsheets for various reasons. I will explain later. And this concept is found in many management science books, especially the two ones which I will show now. And the examples and templates have been taken from these books, and I have modified them a bit to suit our needs. And these are the two books. Introduction to Management Science by Hillier and Hillier, one main book from which I refer so many things. They call it Management Science. And another book, Introduction to Management Science by Anderson. These two books are on operation research modeling. Yeah. I request you to go through this a bit and while. What is operation research? So this definition has been taken from a website. I will, while you go through it, I will brief on what do I want to do. This operation research is a paper that is taught in engineering colleges, maybe in the 7th semester or something, and some have it, some do not have it. The problem with this operation research paper as taught in engineering colleges as of now is it is taught with the board and chalk. Okay. Whereas the full power of operation research is realized only when you start modeling bigger optimization problems. Bigger optimization problems can be handled only with the help of a software. Here I am using Excel solver and a spreadsheet. So once you start realizing that the operation research paper can be taught this way, then I think more and more engineering students or management students will get to know of it. The way it is taught in our colleges is that we take a small problem of 3 variables and we try solving it on the board with so many steps, and the people get stuck in so many iterations will be there, and we get stuck in one thing. And mostly we deal with the X1, X2, X3. You must have seen. I am assuming that the people here are not exposed to operation research. Okay. Because I understand that people with engineering background, maybe they might have studied operation research long ago. I am not going to assume that the people have studied the paper operations. In fact, this is just a modeling paper. A little bit theory is there. I will go through it very pretty fast. This PPT I will be sharing, so you can. This phases of operation research is identification of the problem, formulating the problem, constructing the model, selecting appropriate input data, deriving the solution, testing the model and solution, establishing controls and implementation. This is a phase of operation research. Identification of the problem is that to identify whether a real world optimization problem. This operation research deals with the optimization problems, transportation problems, and then simulation, and then queuing theory, game theory, goal theory, and all that. And I have chosen problems which are related to engineering, optimization problems which are related to engineering. So business optimization only, but I have chosen the problems related to engineering. Okay. And these are the processes that are involved in operational research: allocation, inventory, whiting, and replacement. This allocation process is used in production control problem, maximization or minimization problems. Inventory process is used in optimization of resources utilization, cost effectiveness. And waiting line process is minimization of queues. That is, minimization of queues. And the replacement process is repair decision, replace decisions, life cycle determination, cost effective policy, and all that. Now I will show a brief PDF on what are all the problems that can be modeled and solved with the operation research. As I repeat, I am concentrating on modeling problems and then solving them. Just to have a look at it, I am showing a I will be brief. Financial models can be attacked, okay, and then investment models can be attacked. Production models can be attacked, that is related to you. How to use parts to build different products and maximize profit. Which machines to use to produce products in order to meet a certain demand and minimization. When the end product requires certain qualities and is a mixture of previously produced products, to pick the process among several different ways of producing something that minimizes the cost or maximizes the profit, to determine how to cut steel sheets so as to minimize the waste of steel. So these are somewhat related to engineering. I will touch upon one or two examples, and this one is what is the purchasing models, distribution logistics models, scheduling models, decision-making models, especially networking and project scheduling, and others, transportation, inventory, and the queuing theory, everything is there. All this can be attacked. Okay. Yes. Now I was telling about this modeling optimization problems through spreadsheets. Why do I choose spreadsheets? There are many software. Maybe MATLAB is there, and certain software are sold with the operation textbooks. For example, if you get the book by Hamdi Taha, a Torah software will be given. Why don't you just use that? One problem in using the software, MATLAB and this, you will have to convert the problem into equations, which really scares a non-mathematician. Like x1 plus x2 plus x3 less than or equal to 3, 2x1 plus 3x2 plus 4x3 greater than or equal to 6, like that. You will have to have x1, x2, x3 to feed into this certain software, which may scare a non-mathematician, right? But when you model these problems on spreadsheets, you use certain simple Excel functions so that that takes care of the equations part. I will show you shortly, which will be simple. And I will be using only small optimization problems as of now, which can be solved with a facility called solver provided with Excel. Okay. And the bigger optimization problems, I tell you, large problems, I mean problems of thousands of variables. I repeat, problems with real problems with thousands of variables can be attacked by simply using spreadsheets. Okay. They are solved by a facility called Open Solver, so open space, open source software that can be utilized. Okay, if you have time, I will show that also. Okay, and there are other packages that go beyond spreadsheets. Many may be compatible with MATLAB and other software, but I stick to spreadsheets because it's a very good interface between the person who formulates the problem and the non-technician who views, maybe your manager, maybe your boss or somebody. This viewing is good on spreadsheets. The lengthy words can be there, variables will be there, like that. These advantages are there. And the spreadsheet modeling is to perceive the problem intuitively. Okay, that will help you to perceive the problem intuitively. I love using small pictures then and there. Bear with me. In this session, I am using Microsoft Excel 2007 because that is in my laptop and solver adding. However, you can use any version of this OpenOffice or any other version of Microsoft Excel. Only the menu may differ here and there. Okay. What will you cover in this talk? What can you expect from me? Maybe in another 45 minutes. I will go up to 5 o'clock and leave some 10 to 15 minutes for questions if any. I will try to expose you to the formulation of an optimization problem, business optimization problem in general, of operation research on spreadsheets to solve it and to analyze the problem and to incorporate further managerial inputs. What do I mean by this? You will start building the problem with certain data. Okay. Maybe availability of certain resources. In the last minute changes, managerial inputs will be there. And they will say, you present a solution, we won't accept the solution. And they will say, why don't you just increase this resource is cut, and this person is on leave. So many last minute restrictions will come in. And you can incorporate them very, very easily. You can expand. Once you formulate a small problem with 10 variables, you can just drag it and expand it to a problem of 1,000 variables. Okay. When I expose it, it will be clear to you what sort of problem I am trying to attack. I am not trying to attack any continuous optimization problems. Okay. They are functional problems. I am here with the optimization, business optimization problem, engineering related, of course. So this will be an appetizer to make you curious about how this operation research, even though we studied it in engineering, how do we effectively use it for even for consultation? Okay. What's my expectation? Here I will brief you on this. Okay. And if you want me to do a hands-on workshop, I am prepared. I will need maybe 6 hours or 8 hours to make you work on this, make students or staff work on this. Now I will be giving a demonstrative kind of thing only, and have a pay a keen attention to this, because I am not able to make you. 15 days ago, I made the students of Venugopal College of Arts and Science, Vardhanagar. I sat with them daily for 2 hours for 3 or 4 days to make them work on smaller problems, to gain confidence to handle bigger problems. Now I will only be illustrating. Okay? And I will just outline the procedure. I will come back to it later. You may not follow it now. Just have a look at it. I will transfer all data to data cells, display the decisions to changing cells, engage the constraints using output cells. May not be clear now. I am just showing it to you. I will come back to this later. And the overall measure of performance in the target cell, run the model with test values, run Excel solver, and gain insights for interpretation. Okay. So as I put it over here, I will now, in another 45 minutes, illustrate certain linear programming problems. Okay, many are linear programming problems, including transportation, assignment. And I will touch upon the other kinds of problems if you have time, the decision problems, simulation problems, and all that. Okay. So like this plate induces some curiosity in you. Likewise, I will be presenting varieties of small dosa so that you get curious about this concept called management science. Well, have a look at it. An excuse, I will be using only dollars here because I am writing a book on this, maybe published by international company. So I am using dollars over there. Kindly bear with me. And I have modified certain small problems to suit me. So this company has, I think I will get into that. I am showing a small problem to you. This company has 3 plants to produce 4 products daily. Any plant can produce any product. Okay, that's one assumption. Except that plant 3 cannot produce product 4. So I have put in a small catch there. plant 3 cannot produce product 4. I am not naming the products. Okay, it's a generic problem. The unit cost of production for the product 1 are $30, $35, $22 in plant 1, plant 2, plant 3. Then you may say why plant 3 is less and you can throw everything on plant 3, but there is a clash. In the product 2 also, $34, $20 and the $22 is coming over there. And for plant 3, $29, $30 and $25 is coming. And for plant 3, the product 3 is, the cost is less. So that's a competition. So you have to decide which plant to produce which product so that what the production capacities are there, constraints are there. Production capacities are 40, 70, 70 respectively. And the required productions are 30, 60, 60, 30. That is a minimum production I need from that. Find the optimal production that would minimize the total cost. So which product should be thrown to which plant, like this. So before showing the working, I will show the output, the final output on Excel sheet. That's why I told I will put it on Excel sheet that is illustrative, colored, looks nice. So this is how I will plate it on the Excel sheet. Just have a look at this. Let's try to understand the structure with which I put. I will get into the Excel sheet and show the real working there. But see that I have tried to arrange the entire thing as a matrix. Okay. The products versus plants and the cost. Okay. This can be put in a matrix with plants as rows and the products as columns. Okay. So the first one is like that. Just have a look at it. The first one is like that. Okay. And the second matrix, I am putting there the restrictions. More restrictions can come, right? So here I am putting the plant 3 cannot produce product 4. I am putting a 0 over there so that I will be equating it later. Okay. And the third one, here the yellow ones are there, you see, this is the variables. So this will say which plant should produce which product, how much, and to maximize the total cost. And the capacity I have put here in alignment with the row plants. Okay, plant 140, plant 270, and plant 370. Total production I have put here. So two constraints. One constraint is the original plant production must be less than or equal to the capacity. So it is finally equal. This is the solution. And the total production, required production must be equal to the total production. If they say minimum 30 is needed, then you can put greater than or equal to. Okay, over here. You can put greater than or equal to over here. So equality can be replaced by greater than or equal to whenever needed. So have a look at the problem first. I will leave 1 or 2 minutes so that you understand the problem. Then I will illustrate how I solve it on Excel sheet. Just have a look at it. Try to comprehend the problem. Yes. So basically, there are plants, there are products, plants versus products, and the restriction on the capacity of plants are there, requirement of the product is there, and the cost of production of each product in each plant is given over there. Let me go to the Excel sheet and how do I put it on the Excel sheet? I'll be using a very, very simple formula in the Excel sheet, the sum product. Okay. It has loaded. I will maximize the problem so that you have a look at it. Yes. Don't bother about these things. I will tell you later. Now, see that I have put here in this 3x4 matrix the data given. So that's the first thing I do. Okay, what's the data given? The cost of production of in each plant versus each product. But of course, plant 3 cannot produce fourth product as of now. As of now, that is a difficulty. So I will make it as a constraint, and here I am putting the cost as 0. Okay. The advantage of making this is you can easily make it. If 30 is here, I can easily access 32 and proceed with the problem. But whereas when you do it manually, and if you just say by mistake I put 30 instead of 32, you will have to rework the entire problem. That is the difficulty the student faces when he tries to apply to the real world problems. Okay? So this is how, this set of blues, I call them data cells. I have colored them. How do you color a cell? Put it in a cell, go to the home, go to the bucket over here, fill color. With that you can just click and fill a color. I filled it with yellow here. Okay. Yes. So these blue cells, I call them data cells. I enter the data there. The cost of production of each product in each plant is given there. Then this is also blue. This is a capacity. This is the capacity of the plants, plant 1, plant 2, plant 3. So that also I am putting as blue. Another blue I am putting here is the requirement. The required production, the needed production is recorded here. So I call them data cells. I don't change it during the course of the problem. In the beginning of the problem, I can always change it. Next, I am for the beauty with spreadsheets, each one can model in a different way. Okay, I am putting a 0 here. I can just make it as a constraint. I am putting it here also. Okay. Then this also I am treating it as data because this says plant 3 versus plant product 4 cannot be done. So another matrix I have put these yellows. These yellows I call them changing cells. Let me delete the data. So these empty cells are there, empty cells. They are the changing cells. That means they are the variables. They are how many variables are there? 3x4 variables are there. How much product 1 in plant 1, how much product 1 in plant 2, how much product 3 in plant 3 versus so plant versus product 3 plants versus 4 products, 12 variables are there. So I call them changing cells and shade them with the yellow. Okay. No hard and fast rule. You can put any color. Then I will have to engage the target cell. Let me come to the target cell. Target cell gives me the total cost. So how do you get the total cost? The production in plant 1, product 1, the production in plant 1 of product 1 is to be multiplied with 30 to get to the cost of producing a unit of product 1 in plant 2. Okay. So likewise, when you multiply 34 with the units produced of unit 2 in plant 1, you multiply these two. So all these products must be summed up. Okay. The cost in each plant and product, the cost in each matrix to be multiplied with the solution in each cell. So this is called sum product function. Let me see that. You see here, I will type it out for you in case you need. This is, if you see in the formula, it will be there, sum product, the product of, the sum of products. Okay. How do I do it? I will illustrate it over here. I will put a equal to there. Any formula starts with the equal to, then sum product, as we typed, it will appear there also. Sum product means product of all sums. Let me mark the cost matrix. Okay. And then I will put a comma over there. This is the application of this. And then I will multiply with the production matrix and I will close it. Okay. So you see that what is displayed there, unit cost versus daily production. I can name a cell in the Excel sheet. How do I name a cell? For example, I am marking M1. You see here, you are seeing it as M1. I can name it as, okay, I will name it as what? Okay, Ram College. So, I should type it, press enter. That means this particular M2, if you see there, it will be shown as M2. If I come to M1, it will show college. That means that cell has been named. You see that this entire product matrix, I have renamed it as unit cost, and this yellow matrix, I have named it as daily production. So the total cost is the product, some product of the matrix, unit cost and the daily production, entry by entry, and adding all this. So this is giving me the total cost. And in most of the linear programming problems, transportation problems and all such sort of this, we will be using only few functions, and one of them is some product function. Okay. So this takes care of the objective. Objective is to minimize the total cost. So the objective cell, I am calling it as target cell, and it is shaded with one color. And I have some intermediate cells. This gives me the constraints. What's a constraint here? What do I mean? The sum of all products in plant 1 cannot exceed 40. Okay, that is the capacity. So sum of this plant 1 product 1, plant 1 product 2, plant 1 product 3, plant 1 product 4. This is the sum. I have used there just the function sum, SUM. So what do I do there? Put equal to SUM, open the bracket, and then I will cover the first row and close the bracket. Done. So like this, I have obtained the sum of production in plant 1 cannot exceed 40, sum of production in plant 2 cannot exceed 70, sum of productions in plant 3 cannot exceed 70, which is one constraint. Next, the total production of the product 1, wherever it is produced in plant 1, plant 2, plant 3, it should be 30 for me. It should be equal to 30 as of now. If I want it to minimum 30, then I will put to greater than or equal to. Okay. If maximum 30, I will put less than or equal to there. So the sum of product 1 in all plants, sum of product 2 in all plants, sum of product 3 in all plants, sum of product 4 in all plants must be equal to the requirement, the required production. So I have added it there. Okay. Okay. Then, so these are the things, data cells wherein we dump the data, and the variables are the changing cells where it keeps changing, and what is this? Transition cells, there are output cells which gives me the inequalities, and the target cell that defines the target. So after having decided, how do I solve it? Now I think you now understand the coloring. What is coming here? It is the name. So the range of cells H14 to H17 has been named as capacity. So H14, this one. Okay. So if these three entries, this column matrix, I name it as capacity. What's the need? The person who is not well versed with the problem, but he can understand, one who can understand the problem with wordings, then they should be useful. So where is capacity? Where is the daily production? Where is plant 1? Plant 1 production is this first cell. So this is called plant 1 production. So I can highlight it and show to a person who is a non-mathematician or who is not interested in your formulas. He wants to know where is what, and if you want to send this to someone, he must understand where is what. You can name them. Okay? Now, after having formulated this, how do you solve this? You have to go to data tab. There will be a menu called solver. If it is not there, what to do? I will tell you. You should go to the globe button in the left extreme, left top, left of the Excel sheet. Maybe in other versions it can be somewhere. Go there and go to Excel options. Go to Excel options wherever it is. In the Excel options, go to add-ins menu. And once in the add-ins menu, it's reaching there. It has frozen. Am I not audible?
You are audible, sir. No issue.
Audible. Okay, it has frozen. I will get back to you. Let me explain the other problem. I got into the problem. I will close it and restart it. It has come now. So add-ins button. In the add-ins button, you search for the solver add-in. Okay, there will be a thing called solver add-in, and therein you can click go, and it will be shown like this. And you can check, ensure that solver add-in is clicked, and you can click OK. I am not clicking OK because it is already there. It will automatically install itself. Now let me click the solver. I already have assigned there what is what. What is to be put there in solver. Solver needs to know where is your target cell. Solver needs to know where is your target cell. That is, where is the objective function. The target cell is particularly here, okay, where I entered the total cost. So I must point out there and enter there, and the cell is named as total cost. It is appearing there. Next, it needs to know whether you want to maximize or minimize. Okay, minimization I am putting. This value of is a third option where you will have to exhaust whatever you have in hand. No maximization, no minimization. You will then use it there. Now changing cells. Changing cells are variables. What are variables for me? I will mark here and then shade this yellow. I will shade this yellow. That I am telling solver that this daily production is the variable. Then I have to add constraints. How do I add constraints? For example, if I want to add something, I will delete one and then add that. Okay. You click the add button, and then the left side is the total production. I will select the entire row because there are 4 equalities, but all are coming in the same row. I can equate a row to a row, and Excel will equate element to element. Okay, first to first, second to second, third to third, fourth to fourth. Okay. Then I have options here. Less than or equal to, or greater than or equal to, or int or bin. Bin is binary. Int, if I select int, the output will be only integers. Okay. And I am selecting equality here. Okay. Then the constraint is the right hand side. That is this required production. I am marking it. Okay. Then I will click OK. That will be added. You see that there are mainly the plan 3 production and plan 3 product and plan 3 product 4 production is equal to plan 3 product 4 restriction. That is, I am equating the plan 3 product 4 production in plan 3 to 0. Okay, because I don't want to plan 3 to produce plan 4. It cannot. So I am equating it to 0. I make it as a restriction so that the solver doesn't put any number there. Right. Then plan production less than or equal to capacity is another condition. Another total production is equal to the required production. You type all this, and if necessary, go to options, say that your model is linear, and if you are assuming non-negativity, assume non-negativity. You need not bother about other maximum times, iterations, precision, tolerance. All this will come to use when your problem is pretty big. Your problem has hundreds and thousands of variables, and then you can restrict the number of iterations. You can put in some tolerance. You can ask for the maximum number of iterations and all that. Okay, here very less, you need not bother about that. Okay, so with this entries, what you are supposed to do, you must tell solver the main things. Where are the constraints? That is, which is equal to a what, which is lesser than equal to what, which is greater than equal to what. Okay. And that if you formulate it very nicely, then you can try equating columns to columns. Okay. Then what else can be done? Then you must tell the solver where the target cell is, where is the optimization function, whether it is to be minimized or maximized. And you have to tell where the solver can put its variables. These yellow blank boxes can be used by solver to put variables. Now, having elaborated like this, I am clicking solve button. So it is giving me the answer. It says solver found a solution. Simultaneously, I can click answer, sensitivity and limits and click OK. What it will do, so this is integer constraint, sensitivity is not coming. I am putting it as integer constraints because I cannot produce a 1.5 product. Product with size 1.5, with size 1, I mean number 1.5, whether it is 1 or 2. So I am imposing what is the integer constraint there in the constraint. So the solution has come. It says plant 1 does not produce product 1, plant 2 1 does not produce product 2, plant 1 produces 20 units of product 3, plant 1 produces 20 units of product 4 and like that. And you see that plant 3 does not produce product 4, it is 0 there. And the total cost is $4,500. Okay. It is one example I have shown to you. I will go to further problems. I will not elaborate like this there. Okay. I will show a variety of problems quickly so that you understand the capacity of this using this management science to attack certain problem. This is another quality checking problem. See, a maker produces electronic accessories. Okay, he hires quality checkers at various levels on hourly basis. As you know, the quality checker, they differ by quality. Okay, one quality checker charges heavily, but he can check 50 pieces with 98% accuracy. So 2% loss is there, error is there. Why accuracy is important? Because if he mistakenly clears a product, that product goes to the customer and the customer will want it back, that's a loss for the company. Okay. So 2% inaccuracy is there, but he charges $20 per hour. Level 2 quality checker charges $18 per hour, can check 48 pieces per hour with a 96% accuracy. Level 3 charges $16 per hour, can check 40, you see that the number varies. They check 46 pieces per hour with 94% accuracy. And the level 4 quality checker charges $14 per hour, check 44 pieces, like that. 4 quality checkers are there. Now the maker can hire a maximum of 10, it's a budget problem. Why don't you hire all level 1 quality checkers? Maybe availability problem, maybe budget problem. Okay, I cannot have all of them. Maybe the manager would say, I would rather face the loss than paying so much for quality checkers. My product they are quality only. Okay? So it differs. A lot of restrictions will come. So maximum level 1 quality check, 10 level 1 quality checkers, 12 level 2 quality checkers, and the boss wants 16. Maximum 16 level 4 quality checkers, like that. It goes on. An error made by a quality checker causes $2 to the maker. That is a problem. One error made by, because the product will come back to the company. So $2 loss is there. Maybe you can correct it and reason it again. But at least 5,000 pieces must be checked daily. That is another restriction. 8-hour day, that is another restriction. Only 8 hours are there per day. And the 5,000 pieces must be checked. Find the optimum number of quality checkers to be hired at various levels that would minimize the total cost. Okay. So my problem, optimal number of quality checkers that will minimize the total cost. And you can always say, that maximizes the quality. That also you can say. That will increase the cost. Okay. Now let's see the model, how it is modeled on Excel sheet. How is it modeled on Excel sheet? Just to see, I will go to the Excel sheet and show it to you. So you will have to judiciously include all these constraints there. I am not telling anything about the coloring and all now. Okay, I told you already. I am just showing this solution to you. Okay, so I have encaged the data here, the pieces, accuracy, charges of levels versus the level of quality checkers versus the accuracy. Okay, and the everything for quality checker, the pieces, accuracy, charges, error, penalty, how many can be hired, the maximum number of hiring, working hours for them. Okay, everything is 10 are there, each 8 working hours or 50 working hours are there. So I have arranged everything for level 1, the quality checker level 1 in one row. So things are easy. Okay, then I will have to have minimum pieces quality check is 5,000 minimum. So I am making a provision for it. And the solution is 5 variables are there. These empty yellow boxes. Hired, how many to be hired? So the higher cost must be there, error cost must be there, both put together will give you total cost. And the cost of error per piece I am putting in a cell. I don't use any data directly in the formula, because formulas will appear at many places, and if you want to change the data, you will have to go to the formula and change it everywhere, wherever it occurs. So rather, place the data in a cell and refer to it, that cell in a formula, so that you can simply change it to at only one place. Okay. Now I am running the solver to tell you how many to be hired. Okay. Solver, I have entered the constraints there. Checked pieces greater than or equal to minimum pieces. Hired workers must be less than or equal to available quality checkers. And the number of hired quality checkers must be an integer. You cannot hire 1.5%. Okay. So I am putting solve here. That gives me the solution. Okay. What is the solution? Hire 10 level 1 quality checkers, 3 level 2 quality checkers. Don't get anybody from level 3, level 4, level 5, because the error cost is more in their case. Okay? So this is one another optimization problem. I will go to yet another problem. I will go fast. Third one is a product mix problem. Why I am showing variety of problems? When you look at your problem, you must be able to fit it in one model. Okay? The first model was production planning model. The second one was quality checking model. Okay, so you can fit in your model here. Third, product mix problem. I have to produce certain products in certain ratio. It is right there, right? So if I produce a bike, one bike has 2 wheels. Okay, so for every one bike I need to have 2 wheels. If I produce a car, for every one car I need 4 wheels, like that. So when you have a combination of products, you will have ratio also. The company produces 5 products A, B, C, D, E. These products have to be produced in the ratio 1:3:4:2. Okay, for 1 of A, 3B, and 3C, 4D, and 2E, like that. So this is a product mix problem. The restrictions are listed there. How much units are available, how much materials the products A, B, C, D use, and how much material of 1 or 2, 3 available, and what is the selling price of these products. Just go through it a bit. Selling price of these products, and then how much you can produce optimally, so which will maximize the revenue. Because when you get the profit is the cost, revenue minus cost. Okay, so I want to maximize the revenue. Okay? So this is how the product looks like. Just have a look at it. So I will not get into Excel sheets hereafter, because I am getting close. I will show the model. I have a screenshot. So you see here, this is a matrix of materials against products. Okay. So I have to check the proportionality also. I am putting here separately. I have to check the proportionality also, and I have to check whether it is well below the available. the material one used is less than or equal to the availability of material one. Okay, and like that, and I want to maximize the. So this is how I have designed it. Then energy sourcing problem can be attacked. For example, I have a building. Okay, and then how do I get the energy for that electrical energy for that building? I may get it through electricity. I may get it through what is that natural gas. I may get it through solar heating unit. Each has its own pros and cons. Okay? Electricity, just connect it is always available, but it is costly. The natural gas, if I have access to the production of natural gas, if I have a lot of cows there, I will get cow dung and I will produce natural gas, out of which I can run a fan, I can run a AC. And the solar, if I have sufficient space on the top of the building, I can think of solar heaters for certain maybe AC, maybe computers and all that I can plan. But the requirements are there, electricity, I need 20 units, heating water 10 units, heating the space 30 units like that. And I have other restrictions. The top of the building, the size of the roof limits the largest possibility. So if solar is cheaper, why don't you put all solar? You cannot. That's a limitation. Okay, your top is limited. Okay. Then the other things are there. How much electricity I need, how much water heating, space heating, and all that I have converted into minutes. How is it this modeled? This is a energy sourcing problem. How to optimize the energy resources so as to minimize the cost. Okay, and you can think of any other problem which will fit into this model. So this is how this model is designed, and there are how many variables now? You see 9 variables. So you cannot, in fact, think of solving this without a software. Okay, but when you put it on a spreadsheet, I am showing a screenshot to you. You don't see X, Y, Z there, X1, X2, X3 is not there. Only friendly letters are there, right? So this is the energy saving model. Next one is the maximal flow problem. When do you need this maximal flow problem? Wherein transportation problem is one thing, but maximal flow problem is certainly at one place I will need a number of products wherever it is available in India. Maybe this pandemic time, I may need ventilators certainly at a particular city. I will need 10 ventilators, 20 ventilators, 100 ventilators, a particular city, and I do not bother about the cost. I bother about only the flow from whatever available in Delhi, whatever available in another place. I want 100 ventilators quickly. So this is a maximal flow problem, and there will be transportation restrictions. Few can be transported by flight, few can be transported by road, and all those restrictions will be there, right? So this is a maximal flow problem. I have taken from that book. So you see Western names there, European names there. This is how you transport from one place to another using all possible ways, all possible means of transport, so that you get the maximum flow at one particular place. This types of model is called a maximal flow problem, and this is how it is designed on a spreadsheet. Model looks simple, but yet powerful. Okay, you cannot draw networks on Excel sheet, but it will tell you from where you shift how much to the main place. Okay. Next is a shortest path problem. This is always there in anything. I will have to start from one place, reach another place. There will be so many options. How do I reach that place with the shortest possible route? So this is how it is designed on an Excel sheet. Okay. I cannot elaborate all this now. I am sorry. I am just illustrated only one problem and showing it to you. The idea is to induce some curiosity in you, so that if some of you are interested, okay, you can call me and I will take some hours to demo this. The university to which I am attached, the Sathya University of Human Excellence, is an university which offers education from UG to PhD completely free of cost. We don't charge anything. In line with the principles of that university, I also don't charge it. Don't hesitate to call me. If I am available, I will do this and make you work on your own problem. Okay. The next one, where we make it very quickly, transportation problems can be handled. That is, there will be so many locations, production places will be there, and the dealers will be there, or godowns will be there. So you will have to transport so much from all these production places to all the godowns or dealers or sellers. How to transport, how many units from which location to which dealer, and which is the minimum transportation cost. Okay. And it is not only transportation. You can use it for anything which is assigned. You can handle an assignment problem this way also. For example, if you want to assign jobs to persons, okay, and you will know how a person will work on any other job, how each person works on each job, what is the efficiency level. Okay, if there are 100 workers and 200 jobs, and each person has to be given two jobs, and you have some idea which person does which job better, some rankings will be there. So assignment problems can be attacked using the same transportation algorithm. Transportation problem is attacked like this. Then assignment problems, I tell you, this problem is to assign the bus routes to companies which are bidding over the bus routes. So which is the which company can be assigned which route, so that the bidding is more, you get more money. So you can think of any sort of assignment problems even in companies or during conducting function and all that. If you know the efficiency scaling of each worker against each job, you can simply put it in a matrix and go for the assignment problem. Okay, and the traveling salesman problem can also be attacked. Then decision problems can be attacked. What are decision problems? Decision trees you might have seen. So the problems which you need, yes. Somebody intervene? Yes. The smooth car decision problem is there. This says a person hires, gives a hire firm, gives away cars on hiring, and the strategy, how much car he was to keep ready, 5 cars or 10 cars or 20 cars. Okay? And the demand, low demand, moderate demand, high demand probability is known, and the prior probability is known, maybe based on past experience. What is the probability for strategy 1? What's the probability for the moderate demand? What's the probability for high demand? So these probabilities are uptimed. So a decision problem, that's a decision tree problem. Okay. Okay, that can be attacked. Just to see there, and I think I will have to go to the problem and show you. The decision tree can be drawn on an Excel sheet. Just to have a look at it, I will minimize it so that you see that. So, decision tree can be drawn. You see that different options are there. There is a add-in which can draw decision tree on Excel. Okay, so you see that multiple decisions are there. Multiple decisions are there, so that one decision can be chosen. Yes. Then, yeah. Then simulation problems can also be attacked. Have a look at this problem. Yes. In many cases, you must have heard about Monte Carlo simulation. When do you need a simulation? The simulation is to forecast. You have some history, some data on hand which was observed for over a period of time. Then you can get the probabilities concerned and forecast it for the future. For example, this tourist car operator finds that the data based on past few months data, the car's use has varied so much that the past 200 days the demand is given below. So what is the frequency of the trips? 0 trip to 16 frequencies over the 200 period time, 200 days period time. So 5 trips per week, 30 frequencies 30, and the maximum frequency is at 3. Okay, 3 trips per week has maximum frequency. So this is how it is designed. I will show it to you. See, you can just guess it for 30 days. You can guess it for next 30 days, and the average So in the case it says 3 will be the average demand of the taxi. 3 taxis will be in demand on an average. Okay. So simulation problems can be attacked so that simulation can be attained in various ways like queuing. It can be attacked in queuing. It's 5 o'clock now. I will be closing shortly. Queuing, for example, if you have 2 counters and if you want to know whether more counters are needed, you should look at the queuing and how much time maybe in the production line time. Maybe in a petrol bunk, you want to minimize the waiting time of a car. Maybe in the doctor's clinic, somebody wants to minimize the staying time of the person. Or maybe in a company in this, what is the supply chain, where you can find out where is the delay, where it gets, where is the bottleneck and all that you can get. Wherever simulation is needed to past data will be available, you simulate using Excel sheet for many days or many years or many months. Then what you can do, you can use it to guess something, guess the flow for the next few days or months. Then this is a difficult concept. Still, I will show it to you. There is another set of problem called goal programming problem can be attacked. In usual object-oriented linear programming models optimization, you will have one target. They will tell you one objective function. But you can have 2 goals, one primary goal, one secondary goal. Okay, just have a look at it. I think you can read it out. Okay, somebody, you just to see that. And this goal programming problem, it has got 2 goals. Okay, the management has to supply, if possible, 1,400 gallons of enamel paint per week to a sister concern. This is one goal. Okay? And another goal will be to minimize this. There are 2 options, preemptive and weighted options are there. I will show it to you, the preemptive model. So this is how it is designed. The goal 1 to avoid overtime, goal 2 to maximize these goals. Okay. One goal is to avoid overtime. Another goal is the profit of 2,000. Another goal is I want to supply to some sister concern. So at the same time, you can attack one goal, second goal, third goal in an optimization problem. You can have multiple goals. That is called goal programming. Okay? That can also be attacked. Next, it is there already. Then, a last one I will touch upon to show, may not be directly engineering related, but it's a media advertisement problem. This can be used for other problems which fit into this model also. This is exactly, I have many options to advertise in newspaper, television, radio, many newspapers, many television videos, many televisions, and many, what is that, Mirchi radio and all that. Okay, and many weekdays, many slots will be there. So if you expand the problem, it will go like anything. Many TV slots, many newspaper places, front page, back page, middle, size of that advertisement, television slots, between the serial, after serial, what is the time, prime time, and all that will be there. So with this, all this under what will be there, the number of exposures will be known by the TRP ratings and all. Okay, so I have a number of options, hundreds of options, and I have restrictions, and I have a goal to achieve the number of exposures. Suppose your company floats out an advertisement. Okay, the company floats out an advertisement, should be seen by many people. Where to advertise, which will maximize the views and at the same time minimize the cost. Okay? Maximum views with less cost. What can be done? That is designed this way. Just have a look at it. The problem can be really made very, very big. Okay? With a lot of television channels, slot 1, slot 2, slot 3. Imagine this problem can really be very, very big, with hundreds of variables. So such problems can be attacked. Okay? So I think I am closing by this one, and I will invite comments or questions are welcome now. Okay? I will close my presentation. Come back to the video mode. Yes, I am available for any questions. This I know that I have made it pretty fast. You may not be able to do it on your screen, on your computer. Still, I hope I have induced some curiosity in you on how bigger business optimization engineering related problems can be attacked. Thank you. Any questions?
Sir, I
Somebody
want
is-
one question, sir.
Yes, yourself, sir.
Yes, sir. Thank you, sir. Sir,
Well,
my
yourself,
question is,
please introduce yourself.
sir,
student,
myself, Sarna Karthik, lecturer of mechanical engineering in PSCR
very
Ramaswamy
nice.
Raja Polytechnic College,
Oh, very
Rajapalayam,
nice.
sir.
Very nice. Tell me, sir.
So my question is, now the output is only integer basis or counting basis? We are getting.
No, not that. Not only integer. Not only
Okay, sir,
integer.
only
I
integer
told
basis
you
output.
the option it can be made on an integer solution. You can have fractional solutions also.
Okay, sir.
By default, only
what
fractional
my
solutions will
question?
come.
Okay, sir. What my question in this case, I get the output in graphical representation is easily to understand the graphical charts. Example for pivot chart, that is one of the examples.
Yes, that is there. But
Because I am not confusing the values because we get the
yes, sir. You can get it in chart. Kindly wait. You can get it in chart, but solver won't show you chart. You can write a small, what is that, macro. It's called macro, right? You can write a macro in the Excel sheet so that the output is shown as a diagrammatic chart or something in another sheet. Solver won't do it directly, but kindly learn writing. This beauty of Excel is you should learn to write small programs on Excel programming, VBA programming. If you do that, you can make the output to come out as a graph also.
What I am saying that the MATLAB is also one of the graphical view of
Yes,
analyzing.
MATLAB is there, correct.
Because everyone it is very visible to analyze the graphical representation.
Yes, very much, sir, very much. But to solve this optimization problems in MATLAB, you will have to convert them into equations and feed it into MATLAB.
Okay, sir. Okay, sir.
That is the disadvantage there. I will have to convert them into equations and then x1 plus x2 plus x3 equations and then do it. I told you MATLAB is always there to solve optimization problems. I prefer spreadsheets to learn the art of modeling. Once you have learned it, you can go for high-end software. No doubt.
Okay, sir. So one more question from same thing. Now I will take out 50 defects in one product. 50 defects in one product, and how to I will analyze the major issues, minor issues, and how to segregate first priority based on the action plan because of the optimization process. If you any idea, sir?
Yes, I will brief you on this. First, in any such problem, you say the product has to maybe the target may be to minimize the defects or something.
Yes, sir. One product, number of issues and to be minimized.
Okay, that can be attacked. For example, in all these optimization problems, you will have to first decide one target or multiple targets. Okay, one target may be to minimize the effect. Another product may be to maximize the look. Maximize the look. The look can be good. Another product may be to minimize the cost or something. Okay? Less errors with less cost and many goals can be there. So there should be a goal, and then you should identify the variables. Okay? Variable can be big. Product 1, error 1. Product 1, error 2. Product 1, error 100. Product 100, error 3. Like that. So you should have a mapping. What are the variables to be addressed? Okay? Then constraints you must attach, because you would like to correct every error in every product, but there may be time constraints, product constraints. You might have to deliver the product whatever it may be in the shortest time. Okay, so take into consideration all constraints, then try to put them. Okay, then that's why spreadsheet will be easier for you. Try to put it as a matrix. So any bigger matrix, try to put it as a matrix on this product versus the errors and all that. Then you can try minimizing the errors in the product.
It's based on occurrence and reduction basis, correct?
Yes, you can do.
Yes. Thank you.
And if you want to guess it, go for simulation. If you already have data, If you want to guess how many errors may come up, we'll try to use Monte Carlo simulation so that you can simulate to know the possible number of errors.
Okay, sir. Thank you, sir. Thank you so much.
Anybody else?
Participants, if anybody is having any doubt, means you can directly ask now.
Or any input you can give.
Yes. Participants?
I can send this materials to you, the PPT, the related books or something I can send to the organizer so that you can go through it. And I learnt it on my own. I did not attend any workshop. It is very easy to learn from the textbook directly. Those books are very much illustrative. I can send 1 or 2 books to my Telegram channel. You can share it from the bigger books are there. Okay. Yes.
Yes, sir. So, is there any questions from YouTube?
Yes, there is a question in YouTube comments. It's from Sugunta. Like a nice presentation, sir. Kindly provide some example for agriculture and horticulture related research.
I will search and post. Okay. As of now, I don't have it here. But keep in mind, any agricultural problem or medical problem or vegetable problem or whatever it may be, the framework is the must. You should have a target, multiple or 1 or 2 targets. The target must be there. Something to minimize or something to maximize, something to optimize. That should be present there because it's optimization problem. Look for in agricultural, whatever it may be, look for that target. Then you must be able to identify the variables. What do you want the problem to do? What is the expected solution should be? So variables you decide. And you must be aware of all constraints. What are the restrictions that will stop you from minimizing or maximizing? If you achieve all these 3, then any optimization problems can be attacked. If I come through any agricultural optimization problem, I will post it to the organizer tonight. Okay? Thank you.
Okay, participants, any other questions? If there is anything, you can ask directly to our expert speaker. Otherwise, you can also later type it to us so that I will forward the mail to our expert speaker and I will get it to you.
There you can also WhatsApp to me. I will clarify your doubts. My number is 6380557735. 6380557735. You can just WhatsApp me. It is there in the presentation. And this will be on the web also. I will share the presentation also, PPT. Yes.
Yes. So, I think there is no further queries.
We can close.
So I think we are at the end of the session. So formally we are going to close the session. So for that I request Sridharan of 3rd year mechanical engineering to give the formal vote of thanks.
Good evening to all. I deem it a great honor and privilege to propose the vote of thanks on this memorable occasion. Let me first start by giving the glory to the Almighty God for making today's occasion a resounding success. First and foremost, I thank our special chief guest, Ms. Dr. Thothathri Venugopal, Professor, Department of Mathematics and Computer Science, Sri Sathya University of Human Excellence, Kalaburagi, who despite his busy schedule has found time to grace this occasion. I thank him for his kindness, his interest, his hospitality and continued support. Thank you, sir. I thank our principal and vice principal for their support for this function. My heartfelt thanks to the head of various departments and faculty for their valuable contribution and guidance and encouragement in all our effort. I owe special gratitude to them who have worked hard and ensured the occasion became a memorable success. I thank all the distinguished invitees present here accepting our invitation. Last but not the least, I thank you, my friends, for the cooperation in making this function a resounding success. Finally, I leave you this inspiring quote by Martin Luther King: "An individual has not started living until he rises above the confines of his individualistic concern to the broader concerns of all humanity." Once again, I thank you all. Thank you for being here. Thank you.
Yeah, thank you. We can close the session.
Thank you for your wonderful presentation, sir. We really enjoyed the session.
Thank you, sir.
can also do for such kind of events in future also.
Okay, thank you.
Thank you. Thank you, sir. So participants, regarding your certificate, you will receive your certificates within 3 days. So don't think that at once you click on you give the feedback link, at once you get the certificate. It is not like that. We have to check everything. So how many time you have spent in this webinar. So based upon this, we will be sending you the certificate. So it will be reaching you within 3 days. Okay. So that's all for today. So we have ended this session. Thank you. Thank you once again. Thank you everyone. Thank you.
Thank you, sir.